So Vaishnavi, we are discussing this network right now. Parallel series. Series parallel or parallel series? What we were discussing yesterday? Series parallel, right? So screen is visible to everyone?
Yes, sir.
Okay. So have you tried this means by yourself? How the derivation will come? Anyone? Have anyone tried this one? Okay. If you not tried, then so see we have a network like this, network A, network B, and here I told you that I1 current is coming, that I1A current is coming. This is port 1 current. This is two port network 1, this is two port network, another two port network 2. So what we are getting, I1 is equals to I1A is equals to I1B, and here it's in the second, if you'll see the left part, you will get to know that V2A is equals to V2B is V2B, all are in parallel connection. So this particular part is parallelly connected. It is parallelly connected, and this particular part, it is serially connected. Serially connected. So we are getting I1 is equals to I1A is equals to I1B because it is serial, and this one is V2A is equals to V2. So all are, it's parallelly connected. That's why the voltages are equal. So what you will get, the equations from here, your V1 equations will be, if you'll apply the KVL in this particular part, so what you will get, V1 is equals to V1A plus V2, V1A plus this network is what? This network is V1, it is VB, V1A plus V1B, and this is your I2 current. So if it is a I2 current, then you will get I2 is equals to if you are assuming this as a I2A, okay, and if this is your I2B, so it will be I2A plus I2B. So if you will solve these equations like this, so what you are getting, V1 into V1 I2 is nothing but it is the combinations of V1A, I2A, I2A plus this is this is this is nothing but what you will get here. This is it's V1B and I2B. So what, can anyone tell me what is the H parameter? H parameter. What is the general equation of a H parameter? Anyone? If anyone know, they can tell me.
V1 equal to H11 I1.
Okay, V1 is equals to H11 I1 plus
H1 to V2.
H12 V2, and second equation is
I2 equal to
H21
H21 V1.
H21 I1 plus H22
I1
H22 V2.
V2.
Yeah. So this particular equation is what? It is your H parameter only. So I am taking H parameter like this, and this is I1 V2, correct? And if you will solve this, you will get HA parameter, right? And this will be V1A into I2A, and this will be HB parameter, and you will get V1 V1B and your I2B. Okay. So sorry, uh, sorry. Yeah. So this will be I1A and this will be V2A and this will be I1B and this will be V2B. So see, your I1A or I1B is equals to what? I1A or I1B is equals to I1 only. So here we can replace this HA as a I1 only. Okay, plus this is HB and this I1B is your I1 only. And this V2A and V2B is equals to V2. So, and here you are getting H parameter as a I1, V2. So these are getting cancelled out. So in a you are getting H is equals to HA plus HB. So if the network is series parallel combinations, write it down. If the network is, this is the combinations of a series parallel combination. So see, in a series parallel combinations, this is your port A network, this is your port B network. In a port A network, it is a two-port network only. This is V1A, this is V2A. This V1, all the V1 combination is what? V1 combination is nothing but V1A plus V1B. If you'll apply the KVL, what you will get? V1A plus this V1B. This is V1B, and your I1A current is equals to I1B current because it is series connected. That's why I have written, instead of a I1A, I have written directly as a I1. And your V2A and V2A, this V2A and V2B, both are, it's a parallel connector. So that's why it will be what? It will be equal to V2. So that's why V2 came. And here it was the general equations for these two port network. So that's why it's a H I1 V2. So these all are cancelling out and we are getting the general solutions that H parameter will be equal to HA plus HB. Everyone, it's clear how we are getting this? Or anyone is having any doubt? Priyanka, any doubt? Vaishnavi, any doubt? Sharon, any doubt?
No, sir.
Okay. Where is Prasanna? She didn't join now? Okay. So this is the concept of a hybrid parameter. So you guys, means you just have to remember this. We had discussed from here. This is, see. So we discussed parallel combinations. In a parallel combinations, what is the combinations? Yt is equals to Ya plus Yb. In a series combination, Z parameter is added. But in a series parallel combinations, H parameter will get added. Right. Now write the another fourth combinations. Fourth combinations will be what? We have taken all the combinations, so it will be series parallel we took, so it will be parallel series combinations. Okay, so suppose you have particular network, this is network A, and this here you have network B. So this and this. So what I am telling, this is parallel series. So here it will be parallel. Can anyone tell me how will be the connection here? If it is a parallel in front side, then how will be the connections? Anyone? Vaishnavi, how will the connection? Priyanka? Guys, anyone? I'm waiting. Just, it's very easy now. Why you are taking so much time? See, if it is a parallel connection, so parallel means what? you just need to put one wire here to here, okay, and one wire from here to here. This means it's a parallel. And for series, you just need to combine this, okay. So if it is parallel, and if I am taking plus minus v1, this I am assuming plus minus v1a, so, and this I am assuming plus minus v1b. So what is the meaning? Parallel means the potential is same. This particular point and this particular point and this particular point, we are getting, we are, see this part, see this part. So potentials are coming same, means v1 is equals to v1a is equals to v1b. And if this is a series, and you are taking this is a positive negative v2a, and this will be positive negative v2b, and overall positive negative, this is v2. Here current is I2 is coming and I2 current is going. So this I2 is nothing but is equals to I2a, okay, and this is your I2a is leaving, and this is I2b, and this is I2b. So from this part, what you are getting from this part, and this you are assuming I1 current, it's going I1 current and I1 current. So if this is I1a and if this is I1b, so what you are getting? I1 is equals to I1a plus I1b, okay. And from this, if you will apply the KVL, what you will get? V2 is equals to V2a plus V2b, okay. So what I am telling, you are getting an equation like this, okay. I1 V2 I am taking in the form of matrices, and this I am getting like I1a, wait, someone came, okay. So if I am getting like this, Prasanna, why you are so late today?
I went out.
You are having a doubt. What doubt?
No. I went for.
Okay, I got it. So okay, so see, so what I am telling, here I1 combination is I1a plus I1b, and here V2 is equals to V2a plus V2v. So if I am writing I1 by V2, I1 V2, so how it will come? This I1 meaning I1a plus I1b, and this V2 is V2a plus V2b. So V2a, this is the combinations like this it's forming now, I1b and V2b. So can anyone tell me what is the G parameter equation? Anyone know the G parameter equation? It's very easy. You should not take that much time for telling a G parameter. Prasanna, what is G parameter?
I1 equal to G11 V1 plus V1.
I1 is equals to G11 what G11?
V1.
G11 V1 plus
G1 to I.
G1 to I2. Okay, G1 to I2, and another one is
V2.
V2 is equals to G21
G21
V1 plus
V1 plus
G2 to
G2 to
I2. So I can write this as of in the form of G parameter is the product of V1 and I2. Everyone is agree with this? And for this can be for the port A. So for port A, we can write as a GA into V1A I2A. Everyone is agree with this? And this for port B, it will be GB into V2B into I2A. So you guys know V1 is what? V1 is equals to V1A is equals to V1B. So this is nothing but This V1 is nothing but it's V1 only, and this I2A, I2A, I2A is nothing but I2 only, I2 only. Okay, and this is GA. This particular is GB, and this is V1 only. V2B is V1 only, and I2A is I2 only, and we are getting this V1 I2. Take it common, means it will get cancel out. So you are getting the G is equals to GA plus GB. Okay, so this is the concept of a parallel series network. Everyone got this, or is anyone facing any problem in this? Anyone facing any problem? Prasanna, any problem? Sharin, any problem? Vaishnavi? Okay, so no issue, means like we have a concept like this. Okay, so write one crux, means I am giving you one note for this. Just note it down. Before that, we have another thing. Uh, there is a cascade interconnection. So write the next heading. Where the fifth one interconnection is cascade interconnection. Cascade interconnection. Cascade interconnection. Okay, this is cascade interconnection. So for cascade meaning,
Adding up together.
yeah, adding means not adding. We have a two, like a train. Okay, like a train network. It's like NB. So NA is there, NB is here. Okay, this is two port network A. This is two port network B. Okay. So positive negative V1 is here, and here you having, or means, or we are taking as a positive negative V2. Okay, now for a port 1, this will be V1A. Okay, this one will be V2A, this one will be V1B, and this one will be V2B. So two port network, how is the two port network? We have I1 current and I1 current is leaving. For port A, what will be the I1A, I1A, and I1A will leave. Okay, so I2A is coming and I2A is leaving. For this, I1B is coming, and here I1B is coming, and here I1B is leaving. So here I2B is coming and I2B is leaving. Here we have I2, and here it's leaving I2. So if we are seeing like this as a single network, we have I1, I1, I2, I2, I1, V1, V2, and if you are seeing this particular as a two port network, this particular as one two port network, so we have I1B is coming, I1B is leaving, I2B is coming, I2B is leaving, and if you have this particular two port network, I1A is coming, I1A is leaving, I2A is coming, and I2A is leaving. So how can we solve this? So suppose from the equations you are getting now, this is parallel, V1 is parallel to V1A, right? So V1 is nothing but V1 is equals to what? V1 will be equals to what? This V1 is equals to what? V1A, correct? Okay, and this I1 will be equals to, this I1 is equals to what? I1A. So we are getting one equation, V1 I1 is equals to V1A I1A. Okay, so if you'll solve this equation, if you solve, what is the transmission line parameter? What is the transmission line parameter? T parameter I discussed with you now. Can anyone tell me what is the transmission line parameter? V1 is equals to AV2 minus B I2, and I1 is equals to CV2 minus D I2. So we are writing for these equations. If you write for these equations, what you will get? You will get what? You will get A parameter common minus I2, V2 minus I2. Let me correct it. V2 minus I2. And you have V1 I1A. So if you have a V1 I1A, what you will get? If you have, so you will get equations like this. ABCD parameter, that is ABCD parameter. Okay, so ABCD parameter of a network multiplied with V2A into minus I2A, right? And you see this V2A, this particular V2A is equals to what? V2A is equals to what? V1B, and this I2A is equals to what? Minus I2B. Okay, so from this we can write ABCD parameter of A into, we are making V1A into, instead of minus I2A I am writing I2A. So for this network I can write ABCD network of A network into ABCD network of B network. It will multiplied with V2. This is V1. This will be V1B. Yeah, I2B. So V1, V2B, and I2B. So V2B is what? V2B is equals to V2. V2B here. See the result. V2B is equals to V2, and I2B is equals to I2. Here we have V2A is equals to V1B, and I2A is equals to minus I1B. So from here only we had concluded this is your, I am writing it as a T network, T parameter, transmission parameter A into transmission parameter B, and instead of V2B I am writing V2, and instead of I2B I am writing I2. And this is your overall transmission parameter, that is ABCD parameter only, T total. Okay, and this is V2 minus I2. This sign will be minus only, because if you solve this you will get, okay, let you assume this only, and this will be minus only if you solve this, because in a T parameter, if you solve this in the form of T parameter, you will get minus sign. And this, if this is a minus I2, so it will be minus I2 only. So these and these are getting cancelled out. So you are getting what? You are getting a results of a T is equals to TA multiplied with TB. So this is the general result. When the network is cascaded, the transmission line, overall transmission line will be the product of TA and the product of TV. Is this clear to everyone? Is this clear to everyone? Sharin, is this clear to you? Prasanna, is this clear? Vaishnavi, is this clear? Or any doubt?
No doubt, sir.
Okay, fine. So if you don't have any doubt, then solve this question. So find the Y parameter for the below given two-port network. Write the question. Find the Y parameter. Find the Y parameter for the below given two port network. Okay, so if you have a two port network like this, suppose this is a network and this is a two port network. Okay, and you have some register, it is connected like this, and it is having a 4 ohm. This particular resistance value is 4 ohm. So what will be the two port network? In this you have given it is given in this, it is given that this two port network y of n parameter, it is given, that is 2 5 minus 1 3. Okay, it is given 2 5 minus 1 3. Now you need to find the overall these as a two port network parameter. Okay, y parameter. So how you will find it? You know the y parameter of these two port network, but after solving this, they had what they did, they connected one register like this. Okay, so how you guys will connect this, how you guys will solve this? So guys, let me tell you one thing. So what means, suppose if any network is like this. Okay, if any network like this is positive supply, this is negative supply, this is positive supply, this is negative supply. If some network is like this, and if you are connecting this wire like this, and means you are assuming and if you are connecting like this, so this is, and some you are taking some random value, means like it's a ground and it's connected. If you connect this as a like this, it won't care. So what you are seeing, this is the parallel combinations na? From this side, it is the parallel combinations na? In a parallel combinations, y is getting added, ya plus yb. So if you find the two port network, you know the two port network of this, if you find the two port network of this, you will be able to solve these questions very easily. So can anyone tell me, if you are assuming like this as a 4 ohm, this is plus minus v1, this is plus minus v2, what will be the y parameter of this? v1 minus, if you are taking as a i1 current and i1 current is leaving, i2 current and i2 current is leaving, considering this as a two port, so what you will get the result? i1 value is v1 minus v2 by 4, i2 value is v2 minus v1 by 4. So what you are getting as a y parameter? 1 upon 4 minus 1 upon 4 minus 1 upon 4 1 upon 4. So this is your y parameter b, and you know the y a parameter, that is 2 minus 1 5 3. So overall y total will be yb plus ya. So what is the result you guys are getting? Just tell me the, after adding this, what you will get? 1 by 4 plus 2 by 4, 9 by 4, minus 1 by 4 plus minus 1, minus 5 by 4, 5 minus 1 by 4, 19 by 4, and this will be 13 by 4. So this network, can anyone see me, this network is a reciprocal or symmetry? It is neither reciprocal nor symmetry, because this value is not matching, this particular value is not matching. So I solve like this, means this is, it's given, it is parallel connected. See the potential, it is parallelly connected. Parallelly connected. In the parallel connections in a y parameter, what is happening? A network y parameter is also given. You need to find the y parameter of simply just a wire. That's it. 4 ampere. So you are assuming a another wire, short circuit wire, v1, v2, and you are solving. You are taking as a I1, you are taking as a I2. Just simply apply the nodal analysis, v1 minus v2 divided by 4, and from here v2 minus v1 divided by 4, and put the value and get the result. So it's a very simple, na? Right? Or if you go with the longer procedure, I will solve this question with the longer procedure also for your convenience. See, suppose this was a network earlier. Okay, so if this was a network and it is given, if you are assuming this, in this network, if you are assuming a positive voltage and negative voltage. Okay, so how you guys will assume, means which is v1, which is v2. So you are assuming this particular as plus minus v1, okay, and plus minus v2. This is as a I1 current, this is a I2 current, okay, and this particular has a I1 current, and this particular is leaving as a I2 current. So for this network, the value of a yn is given, that is 2 minus 1 5, 2 minus 1 5 3. Okay, so it's given 2 minus 1 5 3. So if it is given like 2 minus 1 5 3, so what I am telling, now what you did, what you did, you are making another network from this. If you will make another network from this, suppose you are taking this as a I1, this as a I1, this particular as a v1, this particular as a v2. Now what you are doing, you are extending the wire somewhere, and you are taking some particular x. Now this will become your I1 dash current. Okay, and from here the current will not be same. This was I2. Okay, this was I2, and it will become I2 dash current. It's getting splitted into two different parts, right? So can anyone tell me, means, and suppose you are assuming from here Ix current. So can anyone tell me what is the I1 dash value? I1 dash value, I1 dash will be I1 plus Ix, right now? I1 plus Ix, am I correct? And what is the I2 dash value? I2 dash value, I2 minus Ix, I2 minus Ix. I had applied just a KCL. From here it's getting splitted. So I2 dash minus Ix, I am getting I2 minus Ix, I am getting I2 dash. So guys, what is Ix? This is v1, this is v2. Okay, and suppose you are taking as a v1 dash here, and here v2 dash. So what is Ix value? Apply the nodal analysis. V1 point is here, V2 point is here. So Ix is what? V1 minus V2 upon 4. Okay, this is your Ix value. So substitute this value in the equation. I1 dash is equals to I1 plus V1 minus V2 by 4. Here also I2 dash is equals to I2 minus V1 by 4 plus V2 by 4. Right, we'll get the minus sign is there, so that's why minus is coming. Now guys, you know now, from yn parameter it's given in your question. In your question it is given in the questions itself it is given 2 minus 1 5 3. So if this is a yn parameter, if you will write, so what is the in value? In value is 2 v1 minus v2. What is I2 value? 5 v1 plus v3. Right, substitute this in this, means instead of I1 value you have to write 2 v1 minus v2. So I1 dash is equals to 2 v1 minus v2 plus v1 by 4 minus v2 by 4. And here also I2 dash is equals to 5 v1 plus this is 2 v1 minus v2 and 5 v1 plus 3, that is 3 v1 minus v2, 3 v2. So 5 v1 plus 3 v2 minus v1 by 4 plus v2 by 4. Now you have to take the common and just you are getting the equation I1 dash I2 dash. Okay, you are getting, take the v1 part. So 2 plus 1 by 4 you are getting, right? 2 plus 1 by 4 part, 1 by 4 you are getting, and what you will get here? Minus 1 by 4, right? So you are getting minus 1 by 4. And downside 5 v1, so 5 minus 1 by 4. And what about this? This will be 3 plus 1 by 4. And this will come as a v1 v2. And this v1, its v1 is equals to v1 dash and v2 is equals to v2 dash. See, it is parallel. So v1 dash is just equal to v1 and v2 dash is equals to v2. So I1 dash I2 dash we are getting as a 9 by 4. This is 5 for 20, 19 by 4, and this is 4 12, 13 by 4, and this as a minus 5 by 4. This is your v1 dash and this is your v2 dash. So we got the results for this network, this is our network. So I1 dash I2 dash this is positive negative v1 dash, this is positive negative v2 dash. Is this clear to everyone? Prasanna, is clear for you?
Once again.
See, it's not a very big problem, it's a very simple problem. So what I did, you have a two-port network. See, in the question it is given that this is a two-port network and the network, its yn value is 2 minus 1 5 3. If you write the equation for this two-port network, this value is given for this particular network. So what is the value? Means I1 is equals to 2 v1 minus v2 and I2 is equals to 5 v1 plus 3 v3. You know now to convert this if you have a y parameter. This thing is clear?
Yeah.
Now if this is clear, now what they did, they just added one wire parallel to this network, right? So I am taking a Ix current from this, and this is valid for this particular network. That's why we consider it as a I1 current, this is a I1 current, this is a I2 current, this is a I2 current, and we are considering these as a two-port network, this particular as a two-port network. So that's why different current will come, I1 dash current will come, and this I1 dash current is splitting into two parts, I1 and Ix. I2 dash is splitting into two parts, I2 and Ix. Now you just need to find the value of Ix. If this potential is V1, so V1 minus V2, V1 this potential, V1 minus V2 upon this 4 ohm, you will get the value of Ix. Clear? So I1 dash is what? I1 dash is Ix plus I1, Ix plus I1 by KCL. I1 dash is Ix plus I1, and I2 dash, net incoming current, net outgoing current, apply this, you will get I2 dash is equals to I2 minus Ix. Put the value of Ix, this is Ix. Put the value of minus Ix, you will get this. Now you are having, means you are solving the network of this equation, means network. Now the network become is a I1 dash, and this as a I2 dash, the different network. It's become a total network, I1 dash, I2 dash. This is plus minus V1 dash, and this is plus minus V2 dash. This is representing, this is
అందులో నువ్వు నేను అదే ముగ్గురు
please
ఆయన చెప్పేటోడు ఒకడు.
please off your mic.
పోస్ట్ ఒకటి, స్క్రీన్ షేరింగ్ ఒకటి, ఫస్ట్ రాజు ఒకటి.
Yeah, so what I'm telling, this is I1 dash, this is I2 dash. So V1 dash means what I'm getting, that I'm just, this is representing, this is the replica of this. So now I am solving this particular network for this part. So if you solve this particular network for this part, so you having the equation I1 dash is equals to I1 plus V1 minus V1 by 4 minus V2 by 4, and I2 dash is equals to I2 minus. Now you just need to put the value of I1 and I2. How can you put the value of I1 and I2? With the help of your Y parameter. So with the help of a Y parameter, you know the value of I1, this thing, and you know the value of I2, this particular thing. Just substitute into this, and now what you have to do, you have to take a common. If you will take the common, the things will become like this, and you will simply take V1 as a common and V2 as a common. But see, in this particular network we have V1 dash and V2 dash. So but you know, these V1 dash and V1 are equal because this is parallel. So that's why instead of a V1 I have written V1 dash, and instead of a V2 dash I have written V2. Instead of a V2 I have written V2 dash. Instead of a V2 I have written V2 dash. So we solve the network, and we got the Y parameter. Prasanna, it's clear?
Yeah, got it.
Okay, if it is clear then it's fine. Okay, so this part is clear. Okay, just wait. Yeah. So this was an important question. This was one of the important question. Okay, so now you have another important question. Let's try to solve this question if you understood this concept. If you have a two-port network, like this, okay, this is a two-port network, and from here it is given a T network, okay, it's grounded, the value is 1 ohm, and this is 2 ohm, and this network, it's given y of n is equals to 2 minus 1 5 3. Okay, how you will solve this? How you guys will solve this? This two-port network is parallelly connected. Suppose, means you don't need to go with that method, longest method. Suppose this is parallelly connected with this. So you are taking, and you know the yn value. You just need to find this two-port network. This is 1 ohm, this is 1 ohm, this is 2 ohm. You are taking like this. Okay, positive negative V1, positive negative V2. This is I1, this is I2, and in this I1 plus I2 current will flow. So what will the KVL equation if you'll apply? V1 is equals to 2I1, this, sorry, V1 is equals to I1 plus I2 into 2. So V1 is equals to 3I1 plus 2I2, and V2 is equals to I2 plus 2I1 plus 2I2. So V2 is equals to 2I1 plus 3I2. So what you are getting, V1 V2 is equals to 3 2 2 3 I1 I2. But this is Z parameter. You need to find the Y parameter because this is parallelly connected, not serially connected. So if it is Z parameter, so Y parameter will be what? The inverse of Z parameter. So take the inverse 3 2 2 3 as an inverse. So what you will get? 3 3 minus 2 into 1 upon 9 plus 4 will be 13. 3 and 9 plus 4 will be 13. So what you will get? You will get 3 by 13 minus 2 by 13 minus 2 by 13, 3 by 13. So this is your YB. What will be the Y total then? YA plus YB. So your YA network 2 minus 1 5 3. 2 minus 1 5 3 is simply added with 3 by 13 minus 2 by 13. This is minus 2 by 13. Right. So if it is minus 2 by 13 minus 2 by 13, and this is 3 by 13. Solve and tell me the answer, final answer. 2 plus 3 by 13 is how much? 26 plus 3, 29 by 13. Minus 1 minus 2 by 13 is how much? Minus 13 minus 15 by 13. 5 minus 2 by 13 is how much? 13 into 5, 65. 65 minus 2, 63 by 13. And 3 plus, this is 3 by 13. So 13 3 are 39, 39 plus 3, 42 by 13. So we are getting the final answer, y is equals to 29 by 13 minus 15 by 13, 63 by 13, 42 by 13. The thing is clear for you guys. Vaishnavi, is this clear? Vaishnavi, is this clear?
Yes, sir, clear.
Prasanna,
Yes,
is
sir.
this clear? Prasanna,
Yes,
is,
sir.
it's not clear? Or it's clear?
It is clear.
Clear na? Guna, for you it's clear? Okay. So means like this way we can solve the network. Everyone got this now? So minus 2 by 5. Okay.
Sir,
Yeah.
1 by 5 is dead.
Okay, 1 by 5 will come. Okay, means where 1 by 5 will come?
Y matrix.
Okay, why?
Inverse.
Oh, Y matrix it's given inverse 1 by 5. Yeah, okay. 6 6 6 6. How 1 by 5 will come? It's a 2 na? 9. Okay. Yeah. 1 by 5 will come. So I did some
Sir.
blunder. Yeah. Sure. So just get the result. Means this will be 1 by 5 only. Correct only. So 1 by 5. But the process is same. You just need to solve this. Means this is 1 by 5. Do these calculations. Okay. 2 minus 1, 5, 3. 3 by 5 minus 2 by 5 minus 2 by 5 3 by 5. Just add it and get the result. Okay, procedure. The procedure is clear for you guys now? How to solve?
Yeah.
Okay. So these things we got the results. Now you need to find on a different question. Write the different question. Find the Z parameter of below given two-port network. Find the Z parameter of the below given two-port network. So it's a very easy question. So you guys will solve it very quickly. I know. This is 2 ohm. This is 1 ohm. This is 1 ohm. Solve it, guys. We already solved this. No, we didn't solve this. So this is 2 ohm, 1 ohm, 1 ohm. You need to find the Z parameter. Prasanna, you have 3 minutes and you have to solve. Okay, I'm giving you a 3 minutes. Guys, why are you taking so much time? Just tell me the answer. Prasanna, got it? Vaishnavi?
So y is 2 by 5 minus 1 by 5 and minus 1 by 5 is 2 by 5.
Okay. Vaishnavi, you are getting the same
And
answer.
yb is
Guys, you all are getting the same answer? Tell me. See, what you got Z. I told you Z parameter, not Y parameter. So for Z parameter, you have to take positive negative V1, positive negative V2. This is your I1 current, this is your I1 plus I2 current. Okay, this is your I2 current. So what you will get the equation V1 is equals to 2 plus 1, 3 I1 plus 2 I2. And V2
3
is
I
equal, 3 I1 plus 2 I2 and V2 you will get, V2 you will get 2 I2 plus I1. So what you are
2
getting?
I 2 5.
Yeah, so 3, 2, 1, 2. You are getting the Z parameter.
5.
Z parameter is 3. This is this particular is 1 na, so 1 will come. Okay, 1. So 3, 3, 1, 3, 2. You will get this. This is your Z parameter, and Y parameter will be the inverse of Z parameter. So just get the inverse and tell me the answer. 3, 2, minus 1, and it will be divided by 6 minus 1, that is 5. So you are getting 3 by 5 minus Y parameter is minus 1 by 5 and minus 1
Minus 1 by 5,
and
3 by
2
5.
2 by 5. So
Sorry, 2 by 5.
this is your Y parameter, right? Yeah. If you know means the thing, can anyone tell me, we previously discussed the thing 2 ohm, 1 ohm, and this is 1 ohm. This is your star network na, or T network. Can anyone tell me what is the star to delta conversion? If anyone remember the formula, if you want to make star to delta conversions, what will be the result? Star to delta. So what is the means for a star to delta conversion means if you want to make here and here and here, if you want to make this part, if you want to calculate this part, what will be the star to delta conversion? 2 into 1 plus 1 into 1 plus 1 into 2 divided by 1. So what is the result? What is the result? What is the result we'll get? So if you'll solve this,
5.
5 will get, okay. And if we'll solve means like 2 1, yeah. And if you'll solve from here, if you want, means we got the results from this. Okay, if you'll solve this, what you will get? 1 into 1 plus 1 into 2 plus 1 into 2. So what we'll get? 1 into 1 plus 1 into 2 plus 1 into 2 divided by 2. 1 into 1, that is 1. 1 into 2, 2, that is plus 2 into 1, that is 2, 2, 4, 4, 4, 1, 5. 5 by 2 will get, right? Plus 2 into 1 divided by 2. So that is 5 by 2 will get. And if you want to calculate this, so that is also 1 into 1 plus 1 into 2 plus 2 into 1 divided by 1. So we'll get 2 plus 4, 5. So this will be 5, and this particular is 5 by 2, and this particular is what you got, another result 5 na, 5. So this is your star to delta conversion. Okay, I just asked means you guys remember the formula or not. You have to revise. You have the only one option. Just revise it again and again. How much you can revise the thing. Okay. So write the next question. 2-3 questions after that we'll start the new topic, that is sinusoidal network, and that is very important. Okay. So find the y parameter of the below given to port network. So suppose if this is your network, okay, and if it is a register like this and it is connected like this, and this is your 100 ohm. What is the meaning of this? Can anyone tell me what is the meaning of this? What kind of a connection is this? This side its current is coming like this, so this is series. This side also current is coming like this, so this is series. So for series your Z total is what? ZA plus ZB. This is your ZA, and this particular network is ZB. Solve the ZB network. Means but in the question, you know, it is given YN network. YN network, that is 2 0 0 10. So but if you will, but in a series, what is the story we had seen earlier? The Z total is equals to ZA plus ZB. So you need to find the Z equivalent of this. So draw one particular network like this. Assume this as a V1, assume this as a V2. Suppose I1 current is going, I1 current is leaving, I2 current is entering, and I2 current is leaving. So what will be the equation? V1 is equals to, this is V1 only, so this is V1. V1 is equals to, or we can say, we can apply the KVL. So if you'll apply the KVL, V1 is equals to how much will come? 100 I1 plus 100 I2, and V2 will be, apply the KVL, you will get 100 I1 plus 100 I2. So what is the meaning? The Z parameter is 100 100 100 100. But you know the Y parameter, YA parameter, that is 2 0 0 10. So you need to find the ZA parameter. If you find the ZA parameter, that is the inverse. So 10 2 0 0 and 1 by 20. So what you will get? 1 by 2 0 0 1 by 10. So this is your ZA parameter. So what now you have to do? You have ZA parameter, ZB parameter, so Z total will be, add this. So if you'll add this, what you will get? 1 by 2 plus 100, so 200 by 2. 1 by 2 plus 100, 1 by 2, 1 by 2 plus 100, 200, 1 by 2, 20, 1 by 2. So this is 100 only. This particular is 100 only, and this is 1 by 10 plus 100, 1 by 10 plus 100. What you will get? 1001 by 1001 by 10. Am I right? So 10, yeah, 1001 by 10. So this is, but in the question, what you need to find? You need to find the Y parameter. Now you got again you got the Z parameter. Again you have to do the Y, for Y parameter you have to take the inverse. So this will be 1, this will be, solve the inverse of this. 1001 by 10, 1001 by 10. First solve the determinant. What the determinants you are getting? 1001 by 10, this is minus 100, this is minus 100, this is 201 by 2 into, solve the determinant. So determinant value is 201 into 1001 by 20 minus 1000. So you are getting the Y total value. Okay, like this you will get the value of a Y total. So is this clear to everyone, or anyone is facing doubt in this? Anyone is facing doubt? Prasanna, is this clear?
How you got that ZA matrix 20010?
What was, pardon? What I got?
YA matrix.
See, Prasanna, it is given in a question only. Okay.
Okay.
It is given in a question that yn network is 20010. You understood this is series,
Yeah, I
this
didn't
side
see
is
that.
series, and this side is series. You understood this part?
Yeah.
Vaishnavi, you understood why I had connected means in a series ZA plus ZB is happening. So this part is series, this part is series. That's why we have to consider Z network. But in the question it is given as a Y network value. Okay. So if it is given as a Y network value, actually in a question it's a given in a millisiemens, but I have taken as a Simon. If in a question, so took a different question. Question is like 20010 into millisiemen. So millisiemen means it's the value is 2 into 10
Divided by
10 to the
5.
minus 3. 10 into 10 to the minus 3. Value is like this, but I didn't consider this. Okay, if you will not consider this, so you will the process is not going to change. Yeah, but the answer is going to change. So I just want to make you understand how to solve this kind of a concept. Okay, so suppose yn value is given as a 20010, right? 20010, and this side is a series network, this side is a series network. Earlier we discussed, if this side is series, also in a series connection, this is your A network, this is your B network. So Z parameter of a A network and Z parameter of a B network will get added. So we need to solve this particular network only. So I just took this network, and by taking this network I apply KVL this side and KVL this side. Using this I got the result of a ZB network. Okay, but we don't know the A network. We know the A network in terms of a Y parameter. So that's why I solve the Y parameter, and I just solve from that Y parameter I got the ZA parameter. Then what I did, I just added ZA and ZB. If you'll add ZA and ZB, but in the question they had asked the Y parameter. So you know the total Y parameter, you know the total Z parameter. So just take a inverse of this and get the result. The process is clear for you, guys. Is this clear, Vaishnavi?
Yes.
Guna, it's clear? Vaishnavi, it's clear? Okay. So, Prasanna, you are understanding, or you are facing, if you are facing any doubt, you can ask. Means this concept took time. That's why I'm asking. You are getting the things, or simply you are saying yes.
So according to the diagram, we have to consider whether it is in series or parallel. First, we have to look into the diagram, and then only we have to proceed, right?
Yeah. So what you had said, that is correct only. So you have to follow like this. Okay. So this part is clear, then it's fine. Now suppose I'm giving one question. You have to find the T parameter. Okay, T parameter, transmission line parameter. So now come to the concept of a transformer. Means like, if we have particular transformer like this, okay, this is n:1 ratio. Okay, this particular is a I1 current, this particular side is a I2 current, this is positive negative V1, this is positive negative V2. Okay, and means you need to find the T network. This is your what? It's your two-port network. So this particular is your two-port network. So how you will get the results of a T network? This is your two-port network. So how you will get this if this is your two-port network? So you have to find the T network. So can anyone tell me, means a T network, what is the combinations? V1 is equals to AV2 minus BI2, or I1 is equals to CV2 minus DI2. Right? This is the equation of a two-port network in a T parameter. So V1 by V2 is equals to N by 1. Okay. So V1 is equals to N V2. Okay. But I1 by I2 is equals to 1 upon N. These things you know now in a transformer. V1 by V2. Guys, I'm asking to you. See, for a transformer always remember, this concept is very important. Okay, always remember, if I1 current is coming from this, so there will be some dot polarity parts and all we'll discuss in a machine, but right now you have to remember like this. If I1 current is coming like this, and if I2 current, suppose I2 current is living like this is positive negative V1, and this particular is positive negative V2. This is N is to 1, means number of turns ratio is N, and there is a number of turn ratio is 1. Okay, N represent actually N1 by N2. Okay, means N1 and N2. So and we can represent like this also, small n is to 1. If you will solve this, you will get as a N1 and N2 in the form like this. Okay, so this small n means number of turns in this side and number of turns in this side ratio. Okay, so here the basic means V1 upon V2 will be equals to what? N by 1, means V1 by V2 is nothing but N1 by N2. This N is N, meaning N1 is to N2, and I1 by I2 is equals to N2 by N1. So this means what? I1 by I2 is equals to 1 upon N. Okay, Prasanna, it's clear, the theory is clear, means this part. Prasanna?
Yeah.
Yeah. So see here what is the directions taken? This directions taken, na? If you will assume in this direction, this I2 will become what? Minus I2. Am I correct? Right? So this is minus I2 actually. So because in a transformer it is applicable like this, these directions, but in a two-port network they had given in a questions the current is I2 in particular these directions. So if you'll assume the current in particular in these directions, then this I2 will become minus I2. So that's why current in these directions and current in these directions ratio, so I1 upon minus I2, you will get 1 by N. Okay, so you are getting V1, see, you are getting what you are getting, I am telling you. I1 you are getting as a minus I2 by N, and V1 you are getting as a NV2. We can write it as a V1 is equals to NV2 minus 0 I2, and we can write it as a I1 is equals to minus 0 V2 minus 1 by N I2. So this is your B, this is your C, this is your D, this is your A. So what is the ABCD parameter? ABCD parameter is N 0 0 minus, in place of, because here also minus is there, here we are also getting minus, so you are getting 1 by N. So for a transformer your ABCD parameter will be n 0 0 1 by n. Okay, let me correct it. If it is transformer, this is n is to 1, where n means n1 by n2, and I1 current, this particular is I2 current, so the ABCD parameter will be ABCD parameter will be n 0 0 1 by n. Prasanna, it's clear how we are getting n 0 0 1 by n, or you want to repeat it again?
One thing.
Okay. See, what I am telling, suppose you have a network like this. This side V1 is given, this side positive negative V2 is given. Okay, here the current in we are assuming it as a two-port network. Okay, so here it is I1, and from here I2 current is coming. Okay, but in a real transformer, the solution is like this. Suppose it is I1 dash, I1, this is I1 dash, and this is I2 dash. Means current directions is like this, then, and this is positive negative V1, and this is positive negative V2, and the ratio is given as n is to 1. Actually this n represent n1 by n2, means the number of turns this side and the number of turns this side. So but in a logically in a many notation wise, it's written as a n is to 1, a small n is to 1. Okay, n is the ratio between the primary side by the secondary side. Okay, so what I am telling, V1 upon V2 is n1 by n2. This primary side current, this primary side voltage will be divided by the secondary side voltage, will be the ratio of the primary side turn to the ratio of the primary side turn, secondary side turns. So this can be written also as V1 by V2 is equals to n1 by n2 value we consider as n1 by n2 as a small n, so n we consider. So we are getting V1 is equals to nV2. Okay, but
What n represents its number of turns?
n represent number of turns.
Okay.
A small n represent the number of turns in the primary side divided by the number of turns in the secondary side. Okay, a small n, this small n means number of turns in the primary side divided by number of turns in the secondary side. Got it?
Yeah.
It's just a notation, just small n. Either you can also write this as a n1 by n2 into V2. It's up to you. And these it's taken as a n1 by n2, it's taken as a small n. Okay, it's up to you. So see the current directions, particularly see the current directions. Current is going in this direction and current is going in this direction. But what is here? The current is going in this direction and current is coming in this direction. Right, in the question it is given. If you want to make this current in particular in a this directions, then what you have to consider? Minus I2, right? If you change the sign of the directions, then it will be minus I2, right now. So this is n1, this is n2, and n1 by n2 is equals to 1. So your V1 by V2 will remain, and n1 by n2 is equals to a small n. So V1 by V2 will remain a small n, that is n1 by n2, and you are getting the V1 value is V2 into n. Okay, and I1 by minus I2, because you have to take the considerations, the sign, the current direction in this, but in the questions the current directions is given like this, so that's why we are considering in this particular in this direction. So that's why it's minus I2 is coming. Minus I2 is equals to 1 upon n. So if you solve this, so I1 value, what you will get? Minus I2 upon N. So what is the general equation of a transmission network? General equation of the transmitter network is V1 is equals to A V2 minus B I2, and I1 is equals to C V2 minus D I2. So you have V1 is equals to N V2 minus 0 I2, and you have I1 is equals to 0 V2 minus 1 upon N I2, right? Minus 1 upon I2, correct? So your, what is your A? Compare this. A is N. What is your B? Minus means this is minus also, this is minus also. What is your B? B is 0. What is your C? C is also 0.
0.
What is your D? D is 1 by N. So what
1
is
by
your
N.
ABCD parameter? N 0 0 1 by N. So this is your T network. Everyone got it?
Yes.
Vaishnavi, you understood? Vaishnavi, you understood?
Sir, I think that is minus 1 by n.
See, Vaishnavi, here it is in the questions, means in a general equation it's minus D na? It's a minus D na? Here also minus sign is there.
Yes, sir.
So that's why we have to take the D only, D part only. So that's why we ignore the minus sign. Right?
Okay, sir.
Okay. Okay. So we have to solve like this also, this only. Okay. So, and this is the transmission parameter. Okay. Now if you understood this particular thing, yeah, see, okay, now only two things is left. Just it will take 10 to 15 minutes. Okay. Suppose you have a network like this, okay, and you have another network like this. Very important question, so please listen very carefully. It is going to be used in power system. You are assuming this as a Z1. This is your two-port network. Means this is positive negative V1, this is positive negative V2. I1 current is coming, I1 current is leaving, I2 current is coming, I2 current is leaving. This is I1, so it's not I1 dash. So you can what you can do, you can divide this two-port network in a two part, okay, like this, like this, like this, like this. You can divide this two-port network in two separate parts. So you have two cascaded connections. One is your this network, this is your two-port network, first two-port network, and this particular is your second two-port network. You guys remember, in a cascaded two-port network, what is happening? Total equivalent is TA into TB, right? In ABCD parameter we had seen. So you need to find the T transmission line parameter of this network and transmission line parameter of these network, and both will get multiplied, right? So if you have, means first network, you are considering about your first network, this is ZA, and this is I1, this is I2, positive negative V1, positive negative V2. Can anyone tell me what is the transmission line parameter of this network? What will be the transmission line parameter of this network? V1 minus V2 upon ZA is equals to what? I1 current, and V2 minus V1, V2 minus V1, V2 minus V1 upon ZA will be your I2 current, right? What is the general equation of a two-port network? V1 is equals to A V2 minus B I2, and V2 is equals to C V2 minus D I2. So make in the form of like this V1 equations. So if you will make the form in this form, what you will get? Minus V2 is equals to I1 into ZA. Okay, V1, and here that V1 is equals to, here it will be I2, sorry. V1 is equals to A V2 minus B I2, and I2 is equals to C V2 minus D I2. Okay, so you guys have V1 is equals to V2 plus I1 ZA plus I1 ZA. So what you need? You have V2, but you need I2. Okay, you need I2. So how you will get this I2? From the another equations, from the second equation, and this is your second equation. So V1 is equals to V2 plus, put the value of I1. Okay, so put the value of I1. Okay, but see, if you will solve this like this also, V1 is equals to V1, you are getting V1 is equals to V2 plus I1 ZA, but you need what? You need I2. How we'll get? Okay, let's try. Just put the value of I1 in this. So you will get V1 minus V2 by ZA, and this is I1. Okay, and from, but you need to get in the relations between. Okay, first try this. Okay, V1 is equals to, take the V2 common. If you will take the V2 as a common, this particular is a ZA, right? I'm really sorry, means I did some mistake here. Okay, so V1 minus V2, we have I1 into ZA, and V1 is equals to V2 plus I1 ZA. From this we need to get the transmission line parameter, right? Okay, if you will not consider this also, we have another method. Don't make it too hectic. We'll take the KVL. KVL is a very good option. So V1 is equals to I1 ZA plus V2, right? And this I1 is equals to minus I2. Simply I1 is equals to minus I2. Don't make in this way, just make it as a very simple. So if you will solve this, V1 is equals to, instead of I1 you can write V2 is equals to I1, instead of I1 you can write minus I2. So minus I2 into ZA. You are getting the first equation. What about the second equation? Second equation is this is only I2 is equals to minus I1. You can write like this: I2 is equals to 0, V2 minus I1. So what is the ABCD parameter? A is 1, B is minus ZA, C is 0, and D is minus 1. This minus will not come, sorry, because in a ABCD parameter we are already considering minus sign. So this minus will not come. So 1 ZA 0 1. Prasanna, this is clear, means how we are getting this value 1 ZA 0 1. See, I will solve it again. See, listen, this is very important. That's why I'm considering too much focus. See, you have a ZA part, you have positive negative V1, you have positive negative V2. This is your I1 current and I2 current, ABCD parameter general equation is ABCD parameter is V1 is equals to A V2 minus B I2, I1 is equals to C V2 minus D I2. So apply the KVL. Here it is directly we can see this I1 is nothing but equals to minus I2. So we got this equation. We need to solve the KVL. So V1 is equals to I1 ZA plus V2. So instead of I1 write minus I2. So V2 is equals to V1 minus I2 into ZA. So we got this equation also. Substitute the value of A. A is 1. A is 1. B is ZA. C we have D part. D part is 1. C is nothing. It's 0 V2. So 0. Prasanna, it's clear? How we are getting this?
Yeah.
Okay.
Yeah.
So our first part is done. Means like we got the port A, T transmission line network A we got. Now solve the transmission line parameter B. If you will solve the transmission line parameter B, now assume you have a connections of ZB. Okay. Take it as a V1. Take this as a V2. This is your I1. This is your I2. So from here we can directly say now V1 is equals to V2. Clear? This is a parallel connection. So V1 is equals to V2. Apply the KVL. V1 is also equals to how much? I1 plus I2 into ZB. Because this current is going to come inside now. So this current is coming inside. So I1 plus I2. So I1 plus I2 into ZB. So we are getting one relations. V1 is equals to I1 ZB plus I2 ZB. But what is the general equations of a ABCD parameter? V1 is equals to AV2 minus B I2. And I1 is equals to CV2 minus DI2. So see, okay, these equations we can write like this. Okay, we have V1 is equals to V2 minus 0 I2. From here we have, but we need in terms of I1. Okay, I1, and we can make this as, because V1 is equals to V2, so we can make V2, that's I1 ZB plus I2 ZB. So in terms of I1 you need, so I1 ZB is equals to V2 minus I2 ZB. Divide this side, you will get I1 is equals to V2 by ZB minus I2. You got your this equation, hence this particular equation. So from this, if you are considering what is the value of a C, you are getting 1 by ZB. What is the value of a D, you are getting 1. What is the value of a A, you got 1. What is the value of a B, you got 0. So what is the two-port transmission line network in this ABCD 1 0 1 by ZB, and this is 1. So what I am telling, for this particular network, if the connection is ZA and this is connection is ZB, so you know the transmission line of A and you know the transmission line of B. Transmission line of A, what was the result for transmission line of A we got? Transmission line of A, what we got? 1 ZA 0 1.
0 1.
Yeah, and what is the transmission line of a B we got? 1 0 1.
1 0 1.
Okay.
1 by ZB 1.
Yeah. So what will be the overall transmission line? The product of this. Solve overall T is equals to TA into TB. So get the results. So if you'll solve this, what you will get? 1 into 1, 1. Z, it will come how much? If you'll solve this, 1 into 1, ZA by ZB will come. Right? ZA by ZB means, see what I am telling. You have 1 Z1, 1 by Z2. So this is getting multiplied with this, and this is getting multiplied with this. So if you will get multiplied with this 1 into 1, so plus 1 will also come. And if we will multiply by this, so ZA by ZB plus 1. We just multiplied 1 by ZA into 0 by 1 matrix into 1 0 1 by ZB. So we'll get the result like this. This will be ZA, and this will be, if solve for this, 0 into 0, 1 by ZB will come, and this is,
by ZB.
yeah, 1. So
1.
yeah, so what is the overall results? Means your total T para network is 1 upon ZA by ZB into ZA into 1 by ZB into 1. So remember this point. We are going to use this again and again in a power system. They will make a connection like this, they will give you a connection like this, ZB, and they will ask you overall T parameter. So overall T parameter, how to remember? In the first part, see, you have to make ZA here and 1 by ZB. So see, it seems to be like it's going down, that's why 1 by ZB. Okay, means it's to remember, this thing is to remember. So it's going to be down, so that's why 1 by ZB, and both are getting multiplied, so ZA by ZB. Here 1, so that's why 1 is getting added. So by this you have to remember this particular, this is very important, it's going to be used again and again. So directly you have to use these results. So you know how it's coming. We are taking as a separate network, this as this, and then we are just cascading this, and we are getting the result. Vaishnavi, it's clear for you how we are getting this? Guna, it's clear? Prasanna, it's clear?
Yeah.
So if it is clear, then it's fine. We discussed today's a lots of topic. So suppose means yeah, how can you solve this question? Means like it's a very important question. If you understood this now, you will be able to solve this question. A question is like this: you have a 2-port network, the value is 2, and here some another transmission line network is given, T network is given, the value is 3 4 2 3, right? And here it is given the value like it's 2. So how you will solve this? So it's very easy na.
Total will get 3 matrices.
Total
Three
will get
matrices
total. So this is your ZB matrices, you remember, and this is your ZA matrices, you remember,
ZC.
and this you have to consider like this. So what was the result of this kind of a matrices? What was the result of this kind of a matrices? 1 0 1 by ZB means 1 by 2 1. You got this. This will be 3 4 2 3. And what was the result of this matrices? 1 ZA means here 2 is given, and it is 0 and it is 1. Multiply this and get the result. If you multiply this, what you will get? 3, this is 2. So 3, 1 1 3 1 3, and yeah, if you are multiplying this, what you will get? Just solve it, multiplication. So you will get 3.
3,
Yeah,
3, 4, 7 by 2,
7 by 2,
5.
5. Yeah. Okay, 5 we are getting. Now you have to multiply this with this. 1 2 0 1. What you will get? 3 6 plus 4 10, and this is 7 by 2 only, and this is 7, 7 plus 5, 12. 17 by 2. 7, 7, 7 are 14, 14 by 2 means solve this. What you will get, Prasanna?
So 1.
1. 1 you will get.
I said 1 minute.
Okay. Oh yeah. So means 7 by 2. See that is it is multiplied with this. So 7 is coming. 7 plus 5. 12 is coming now. 7 by 2 into 2 plus 5. 7 plus 5. 12 you will get. Okay. Right. In the question it is given as a 1 ohm, but I took as a 2 ohm. So that's why. Okay. Is this clear? Prasanna, is this clear?
Yeah, clear.
How to solve this question? Okay, so write one question again, because you have to practice this again and again. If you have a question like this, suppose this is 1 ohm, this is 1 ohm, what will be the net equivalent T parameter? What will the net equivalent T parameter? One one zero one 1 0
1 0 1 1.
1 1. Solve this and get the result. Or you can write directly
2 1 1 1.
2 1 1 1. Okay. And you can directly also do the calculation what I told you. Means put the 1, it's 1 by 1, it's 1, and it's 1 by 1, 1 by 1 plus 1. So you are getting 2 1 1 1. Right? 2 1 1 1. Okay. And if the question is like this is 2 ohm, this is 2 ohm, what will the answer? Quickly, 1 will come, this 2 will come, this 1 by 2 will come, this is getting, this both are multiplied, so 1 is coming, and 1 plus 1 we are getting as 2 2 1 by 2 1. You got it, Prasanna? You got it?
Yeah.
Okay, that's good. Now if you got this, just try this question. Okay, Prasanna, let's try this. It's very interesting question. This is 1 ohm. It is given Z parameter. Okay, 2 1 1 2. Now you have to find overall T parameter. For this, what you will do? You know the relations of a Z and ABCD parameter? I told you one relations between Z and ABCD parameter. Hope you remember. Or you forget. You forget or you remember the relations between Z parameter and ABCD parameter. Just tell me. Forget. So why you are not doing revising? You should revise. Means you have to write again and again. Why means make a short notes. If you will make the short notes, then it is going to help you only. Okay. So you have to revise this type of concept, means how our the relations between the Z parameter and ABCD parameter, right? So we know the means Z parameter and Y parameter relations, we know that it's a inverse. H parameter and G parameter, we know that it's just a inverse. But the important thing is that you should also know the relations between Z and T parameter. Okay. Right now. So why you are not revising these things? This thing is very important, means it's very much important. Okay, so try to revise this topic, means uh, tomorrow I will ask these things from you. Okay, so just revise this topic again and again. How much means the means it is very much important because in the examinations, if you'll not remember this concept now, it will take a lots of time. It will take a lots of time. So you need to revise this topic. Okay. And what about the lattice network? You forget or you remember or you forget the lattice network? Prasanna, I'm asking to you. You forget lattice network or you remember the lattice network?
I didn't revise this way topic.
Or you didn't revise? So see, it means like we had completed up to 40% syllabus of a network. So that means you need to fix a time when you have to revise this concept. Okay. Okay. So we'll
Yeah.
discuss it. So let me see it. What was the thing? H parameter and G parameter. We did it. Conversions of a T to Z parameter. We also. So see, remember means like for it was like this. Your Z11 is equals to A by C. Okay, and Z12 is equals to AD minus BC upon C, and Z21 is equals to 1
1
upon,
by C.
yeah, and Z22 is equals to D by C. So this is very much important. Remember this, revise these things, and see here what it's given. Z11 value is given, right? So 2 is A by C. Z12 value is given, 1 is AD minus BC upon C, and Z21 value is given, this is 1 upon C, and Z22 value is given 2, so 2 is D by C. So what is the value of a C? C is equals to 1. What is the value of a D? D is equals to 2. So if you are getting C value as a 1, what is the value of A will come? 2. And you have to substitute these things in this form. So A is coming 2. You got A, you need to find the B value. So you got A as a 2, you got D as a 2, but you didn't got the value of a B, but you know the value of a C as a 1, and this is 1. So what the value you are getting? B is equals to 4 minus 1. So B is 3. What is your T network then? A, B, C, D. Tell me the value of A. 2. Tell me the value of a B. B is what? 3. And C is 1 and D is 2. So this is your T network. And I solve you the trick. How to solve this? How to solve this? What will the value of now? Now only I told you what will be the value of this. 1 upon 1, 1. Just tell 0, 1. Right? We are getting 1, 0, 1, 1. And this network we know, this network we know, multiply this network. So overall T network will get. So T network will get 1, 0, 1, 1 into 2, 3, 1, 2. Solve this matrix and get the results. So 2 will come and this will be 3 will come. This particular will be 2 plus 1, 3 will come. This particular will be 3 plus 2, 5 will come. Right? Guys, have you understood this? How we solved it? Or anyone having any doubt in this? Prasanna, have you understood? Prasanna, I'm asking to you.
Yeah.
So if you are having any doubt, you can ask. Means like if anything is not clear, you can ask.
It's like more formulas to the number.
No,
That's why
it's not like a
it's
more.
confusing.
See, Prasanna, what I am telling na, it's not like a more formula and more the things. What I am telling you na, if you will practice the more and more questions, I'd already given you the basics questions workbook. So you have to try. You have to feel like I have to cover all the important questions. I have to try by myself. when you will indulge in that kind of a question, then only you will be interested. Okay, then only you will be able to know the formula, know the uh, star to delta conversion formula, delta to star conversion formula. So how many problems you will do, then only you will remember this kind of a questions. Okay, the more you practice, the more you learn. So that's why I had already said you guys, you just have to purchase that Made Easy question bank. Have you purchased? I'm not means advertising that Made Easy only. You can purchase any question bank, because if you will have the question bank, then only you guys will do practice. If you'll not practice, then it's not going to be useful. Are you understanding my point? What I am saying?
Yeah.
So have you ordered the book or not? Guys, have you ordered the book or not? It's just a 600 rupees, yaar. Order it. Don't save money for book. It's going to benefit you only, not me. Okay. So we completed the two port network. Guys, congratulations, we completed a two port network, but you need to remember all the formula. You have to revise again and again. So there is a one or two questions, or we will start sinusoidal network from tomorrow onwards. Okay, so chapter 1 and chapter 2 is done. Now 3 4 means we had completed up to 174 pages. 174 pages out of 394, we completed up to 174 pages. The gyrator part I am not doing, because the gyrator is not coming in examinations. It's out of the syllabus, so no need to study the gyrator part. Now we'll directly go for the sinusoidal part. Before the sinusoidal, we need to solve 2 3 questions of a two port network. And please go through the previous notes and remember this formula. That and there is like you have to derive this formula again and again, then only you can correlate how that z11 is coming a by c, z12 is coming ad minus bc by c, z21 is coming 1 by c, and z22 is d by c. Okay, okay guys, so I had recorded the video, I will upload it. So if you are having any problem in this, you so that you can watch the lecture again and again. So that's why I am making a video. But it's not like that you are not coming. If you'll not come, then I will not be able to take class. So you all have to come. Okay? Okay? Okay. I'm winding up the session. Okay, bye, good night.
Bye.
Good night.